Now I'd like to show you how you can look for a matching object based on similar perimeter contours. I'm going to look under the Machine Vision group, come down here to Geometric Matching. Throws an error here. It says we need to be using a grayscale image. Let me convert this color image to grayscale by extracting the luminance plane. All right, let's come back and start up geometric matching. First thing we need to do is click New Template. Draw a contour around the object of interest, in this case the key, and then click Next. All of the green lines indicated the automatically extracted contours. What we need is one single closed contour that encircles the entire key and nothing else. The circular hole in the key bow, that would be okay, but all of these other features need to be ignored. These features are generally resulting from highlights due to the fact that the key is metal and it throws these extra hotspots into the image, especially as I'm showing right here. Now, it would be possible to draw the red regions to ignore certain areas, but it would be more convenient if we just didn't have them showing up in the first place. Let me show you how I can deal with the highlights. I'm going to use the min operator. The min operator says look at every single pixel, and if it's above a certain minimum value, then it's just clipped to that value. I'll show you what I mean here. Look at the grayscale. And you see in the highlight region, it gets very close to the maximum value of 255. Now, if I set my minimum value to 30, I get a pixel value that's clipped to that highest value of 30. I'd like to preserve the grayscale aspect of the key as much as possible, but yet eliminate the highlights. So let's try a little bit higher value of 150. All right, that's tamed that highlight just a little bit. I think I'm going to land on a value of 100 and see how that looks. All right, this grayscale image will be useful, I think, for finding the contour automatically and not throwing these extraneous contours in there. So I'll start over. We'll say New Template. Draw the contour around the key. And this is working much better. We see one closed contour around the periphery of the key, and then we're also picking up one closed contour for the hole. Now I'd encourage you to experiment a little bit with some of the options here. The extraction mode by default is normal. The one called Uniform Regions works best when you have a more or less uniform background and uniform foreground. You can also investigate options for the difference between the foreground object and the background object. That's the edge threshold. And again, you can kind of see that as you experiment with these numbers, you can, in this case, have the detected perimeter disappear altogether because the edge strength is really not that high. So this default value of 75 seems to be working out pretty well. Again, I encourage you to try out some of these other parameters. I'll also mention the one called minimum length. This could be useful if you want to say, I need to have a perimeter that's at least 100 pixels in length, and that would make the hole disappear if you set that higher. Or if it seems like having the hole included in the template is a good thing, then just set that to a smaller number. All right, let's move ahead a little bit. This is where we need to place the coordinate system. You can pretty much go anywhere you like. I'll just pick a convenient location, which is the center of that hole in the key bow. You can also adjust the maximum anticipated range of scale variation. You want to not make that range too large, otherwise it's going to really increase the amount of CPU time required to search for a match. I'll save this away as the template image. This is the image of the region of interest that was drawn earlier, and it also includes all the information about the way that the contour was extracted. Looking at the results, we find that the match score is exactly 1000, and 1000 is the maximum value possible, and that kind of makes sense because that's the original key that the template was based on. Here we also have a pretty very high score showing that the key at different orientations, different presentations to the camera is able to be matched, and it's able to be matched quite well. So I'm seeing that generally these numbers are showing up at above 990 when I'm looking at the exact key. This one that I'm looking at right now is very similar, but it's not exactly the same. So if I use a minimum score that's very close to 1000, it will reject keys that look very similar but are not identical. Again, this key is not a match because it's not the same. Now let's take a look at some of these search options, especially the ones for looking for rotation and occlusions. Occlusions would indicate that we have multiple objects and we're trying to find it if it was partially obscured by another. Scale would say we're looking for variations in size. Just want to point out the cost of some of these options. This is the longest inspection time that's estimated, 335 milliseconds. And that's what we have when we are only looking for rotated objects. If we look for scale variations, let's see how we do. 335 milliseconds is what we had a moment ago. And in this case, the longest inspection time is jumped up to 1300 milliseconds. So you really want to only look for variations that you absolutely expect. The last tab I'll point out here is curve settings, and you will recognize that these are the same values that were entered when we did the original setup of the perimeter template. So you can always adjust those after the fact.